Welcome to lecture 6.2. So, we're returning to the concept of looking at the unit circle, but this time, instead of just labeling the points, if you recall, usually this would be the x values, and this would be the y values. So instead of calling them that, now we're calling them by the other name we know, which would be cosine, remember, are the x values, and sine, which are the y values. Okay. And one other thing to note when we're looking at a triangle on the unit circle, if this is our angle, theta, the adjacent one is right next to theta. The longest one is the hypotenuse. So notice, the hypotenuse and the adjacent one are technically considered adjacent. How do we know which one is the adjacent and which one's the hypotenuse? Well, if you remember, the hypotenuse is the longest leg. So sometimes it's easiest to first figure out which one's the hypotenuse, and then from there, the remaining one is the adjacent leg. And then the one directly across from your theta would be considered your opposite. Okay, so here we have the trig ratios, and these, they may look very different, but they come from what we've been doing basically all along. We've been building up to this. So a little while ago, I talked about something called SOH-CAH-TOA, and it's just a way of remembering the different the different trig ratios or trig functions and how we find them. So is talking about one of them, which is talking about sine, and I'll get to that in a second. Ka is talking about cosine, and TOA is talking about tangent. You might say, well, what about the other three? Why don't they have a special one? The reason they don't have a special one is because they are basically created by taking the reciprocal of these three. And because of that, we don't really need to have a special way to find those. Okay, so what does SOH-CAH-TOA stand for? Well, I did mention it before, but once again, I'm going to go over it again. S stands for sine. And how do we find sine? Well, sine is, and you always, as you read from left to right, the next letter is O, which stands for opposite. So the opposite value. So sine is going to be opposite over, and H stands for, what do you think? Yeah, hypotenuse. So sine is opposite over hypotenuse, which we have right there. And sorry, I think you might be able to hear my golden retriever whining in the background. That's because she has been a naughty dog and keeps escaping. So she's currently locked up. Sorry for that distraction. Alright, so back to this work. So we have, the next one is Ka. So C, once again, that stands for, let me write this up here, cosine. The next one we have is A. So A stands for, the other one left is adjacent. So cosine is going to be the adjacent over, and H stands for hypotenuse. And then the last one for TOA, T stands for tangent. And then tangent is going to be O, opposite, over A, adjacent. So that is how you would find the three main trig functions. And once again, we usually just need these three main ones, and then we can find the other three by taking the reciprocals. So that's the importance of SOH-CAH-TOA. It tells you how to find sine, cosine, and tangent when looking at a triangle. So now let's go ahead and find all the 6 trigonometric values, or ratios. Oh, that should technically be with that problem right there. Okay, and we are given this triangle right here. Okay, so we're given a triangle. We're given, let's see, we have 1, 2, 3 sides we're given. Awesome. So now let's go ahead and find the 6 trigonometric ratios. And finding those, we're going to go ahead and use SOH-CAH-TOA. So talking about sine. So sine of theta. The question is, which angle is theta? We have this angle, and this angle. Well, it's always going to be the one where you have the adjacent and the hypotenuse right next to each other. So here's the hypotenuse, this one right here. And this is adjacent, and then we need to have the opposite one across from it. This is O, which means theta is going to be this angle right there. So let me go ahead and highlight that. So sine is supposed to be opposite over hypotenuse, because once again, sine is O over H. So opposite is 7, and hypotenuse is 25. So sine of theta is going to equal 7 over 25. Cosine of theta is going to be, remember, so ka, So it's going to be a over h. The adjacent one is 24, and hypotenuse once again is 25. Next we have TOA, opposite over adjacent. So tangent of theta is going to equal opposite over adjacent. Opposite was 7, and adjacent is 24. So 7 over 24. Next, we got to go ahead and find the other 6. So if you recall, cosecant is the exact reciprocal of sine. You just flip them, which means that cosecant of theta is going to equal 25 over 7. And then secant is the reciprocal of cosine. So we just take their reciprocal. So secant of theta is going to equal the reciprocal of 24 over 25, which is 25 over 24. Let me go ahead and we shouldn't be using those arrows, actually. They're just going to be the reciprocal. And lastly, we have tangent of theta. So the reciprocal of tangent is cotangent. So cotangent of theta is going to equal 24 over 7. And there we go, we have the 6th trigonometric function. Alright, so example 2. If cosine of alpha, this little guy here is called alpha, if cosine of alpha is 2 over 3, find the other 5 trig ratios. That little ratios, once again, should be right there. Okay, so we know cosine of alpha equals 2 over 3. Okay, how can I find the other ones? Well, if I recall, cosine is also, remember SOH-CAH-TOA, cosine is adjacent over hypotenuse. So, using that, I have my adjacent value and, oops, wrong color, my adjacent value and my hypotenuse value. So let me go ahead and create a triangle. And then, once I create this triangle, I can now find my other points. So we'll go ahead, we'll put our theta here, and then adjacent is supposed to be 2, according to this cosine information we're given. And then what is hypotenuse? Hypotenuse is supposed to be 3. So the only other value we're missing is, oops, wrong color. The only value you're missing is the opposite one. So how do we find opposite? Well, this is a right triangle, right? So we can use a squared plus b squared equals c squared, the Pythagorean theorem, to solve for the missing angle. Right here. So let's go ahead and do that. We'll call that angle y. So know that y squared plus 2 squared should equal our hypotenuse, which is 3 squared. Once again, this is the Pythagorean theorem, which we can use for right triangles. And if you recall, our ratios are from right triangles. Okay, so solving, we have y squared equals 9 minus 4. Then y is going to equal plus or minus the square root of 5. Which one do we take? Well, we're talking about a triangle, which would have a positive length. So we're going to take y equals positive 5. So once again, I don't know if you noticed this, but if you have a plus or minus and you're choosing which one you're going to take, just write out take and then the sign you're using, okay? Alright, so we're using that. So this is square root of 5. Awesome. So now we have all 3 sides and we can find the other trig functions using SOH-CAH-TOA. So then sine of theta, if you remember, is opposite over hypotenuse. So that'll be root 5 over 3. And then we have tangent of theta, which is supposed to be equaling opposite over adjacent. Opposite is root 5, and adjacent is 2. Now let's find the others. So cosecant of theta, alpha, is the reciprocal of sine. So that's going to be 3 over root 5, which we have to simplify by rationalizing. So that'll be 3 root 5 over 5. And then, who else do we need? We need secant. So secant of alpha is going to equal the reciprocal of cosine, which will just be 3 over 2. And lastly, we need cotangent of alpha, which is going to be the reciprocal of tangent. So that'll be 2 over root 5. Once again, we need to rationalize that root. So multiplying top and bottom by root 5. Notice I didn't show it when I did cosecant, and that's fine. And then we have 2 root 5 over 5. All right. Okay, so we found all 6 trig functions. How did we do it? Well, we were given a hint, and we knew with cosine we had that hint of SOH-CAH-TOA, and we could create our triangle. We were missing one of the sides, so we had to use the Pythagorean theorem to find the other side. And then from there, we were pretty much golden. So now, let's look at something considered special triangles. Okay, so note the sides of similar triangles are considered similar if they only differ by a constant. What does that mean? To differ by a constant. Let's see, 2 and 14 only differ by 7, a constant of 7. So it's just basically they're considered multiples of something. So let's take a look at these 2 special triangles. What makes them special? It has to do with the angles they have. So first, let's go ahead and take a look at these 3 special angles. 30 degrees, 45 degrees, and 60 degrees are special. Why? Because they correspond with the unit circle. Let me go ahead and draw a little graph here for the unit circle. They correspond with pi over 6, and then pi over 4, and then, ooh, sorry, that's really squishing in there. And remember, over here we have pi over 3. That's on the unit circle. So 30 degrees corresponds with pi over 6, 45 degrees corresponds with the angle with pi over 4, and 60 degrees corresponds to the angle of pi over 3. And then 90 degrees would correspond with pi over 2, right? If you're looking at a 90 degree on a unit circle. So, with all of those, sine of pi over 6, if you remember, is a half. And so on. So these are all just the values from your unit circle. Nothing new, it's just sort of written out in a different way. So now when we look at these guys that are considered our special triangles, if you have a triangle that is 30 degrees, 60 degrees, and, oh gosh, what's that? It doesn't tell me. That is 90 degrees. So if you have 30, 60, and 90, it's considered one of the special triangles. The question is, how did I know that was a 90-degree angle? Well, if you remember, what is the angle, what is the degree measurement or degree amount inside of any triangle? It always equals 180 degrees inside of a triangle. All the angles measured up should equal 180. So if you took away 60 and 30, you would end up with 90. So that would be 60, 30, and 90. If you have a triangle of 60, 30, and 90, the sides are going to always be multiples of these 3 values. 1, root 3, and 2. Okay, so where they are is also important. In between the 60 and the 90, this angle here, which we would also consider, if you recall, the adjacent angle, is always going to be a 1. Not the adjacent, sorry, that's opposite. The opposite angle is always going to be 1. To the other side would be the adjacent angle, which would always be some multiple of root 3. Either 4 root 3, 5 root 3, 6 root 3, 7, something like that. And then the hypotenuse will always be some multiple of 2. So, a possible triangle for this would be maybe 3 times 2, 3 times 1, and 3 times root 3. That would be another version of a similar triangle. What's another version? Well, any number you can think of, you could create a similar triangle by just multiplying all of these sides by one number. So maybe I could multiply them all by 8, and then I would create a similar triangle with this special triangle that has these specific angles. Note the angles are very important in how we get the sides. So another one that has special angles that'll help give me this sort of a similar triangle idea would be if we have 45 and 45 degrees, and the other one will be 90. And you can find that once again by doing the 180 subtraction. So if you have a triangle that has a 45, 45, and 90, we know this is something we'll know, and it is proven, and if you want to know how it's proved, you can go ahead and let me know that in an email. But basically, all the sides will be some form of a multiple of 2, 1, and 1. So the hypotenuse of your triangle will always be some multiple of root 2, and the other sides will always be some multiple of 1. So for example, if you could pick any number, let's say maybe 8, this new similar triangle would be 8 root 2, 8, and 8. And so on like that. So now let's use this idea to solve example 3. Solve for the missing sides. Alright, so let's take a look at what we're given here. Well, we have a triangle, and then we have some different angles. Let's take a look at the angles. We have a 60 degree, a 30 degree, and we know that this should be a 90 degree by the 180 thing. Aha, that should ring a bell. We know of a 60, 30, 90 degree angle that fits the special triangles. And it's this one right here. Let me go ahead and erase some of this. It's this one right here. So, what I'll know is whatever we have on this triangle, the lengths will always be some multiples of 2, 1, and 3. Sorry, 2, 1, and root 3. We just have to match up the right sides. So this is the 90 degree, and that's the 60. So in between it, that leg is supposed to be a multiple of 1. And right now, we're given 7. So we know that 7 is supposed to equal something times 1. Because remember, it's a multiple. So to solve for that value, we'll divide by 1, and basically, we're looking at multiples of 7. That one, we probably didn't need to do some algebraic form here. You might have been able to figure that out pretty quickly, but that's basically what happens. So we're looking at multiples of 7. Now let's take a look at the other ones. So we know between 60 and 30, that length, or the hypotenuse, is supposed to be a multiple of 2. This is going to be 2 times whatever our multiple was, which we discovered our multiple is 7. So that'll be 2 times 7, which means this leg length is 14, because it's a multiple of 2. Now let's figure out the last multiple, root 3. So this leg is supposed to be something times root 3. And we figured out what that something was down here. It's 7. So that'll be root 3 times 7, which is just 7 root 3. Let me just go ahead and rewrite that a little nicer. 7 root 3. Okay, so I'm going to go ahead and box the answers for my missing sides. 14, 7, and 7 root 3. Once again, they were all multiples of 7. Now let's take a look at the next triangle. We're given a 90, 45, and 45 degree. Okay, so this one, we know, is going to have to do with this triangle right here. So we're looking at the root 2's, 1, and 1. Let's go ahead and match up those sides. So the 90 degree is here, which means between the 45 and the 90 should be a multiple of 1. So this should be some multiple of 1, as well as the other side should be some multiple of 1. And lastly, this side here is supposed to be a multiple of root 2. So 6, we're told that this is equal to 6. So to solve this side, we know that 6 is supposed to be root 2 times some number. Let's go ahead and solve for that. So dividing by root 2, dividing by root 2. We need to rationalize this too, by the way. That'll be 6 root 2 over 2. Ooh, we got to simplify that. 3 root 2 over 2. X. So the number that we are going to be multiplying everything by is 3 root 2 over 2. It's a really weird number, but that's what we're going to multiply by. So to find the other sides, should be 1 times 3 root 2 over 2. And we get, what do you know, 3 root 2 over 2 back. And the other side is going to be 3 root 2 over 2 as well, because multiplying by 1, we're going to get that same number back. So we have found all of the sides. And we're given 6. Alrighty. Interesting. Okay, so now we are given example 4, and we're told to solve for x. Let me go ahead and move this real quick so that it's not blocking our problem as much. Okay, solving for x. Well, where is x in our problem? X is along here. What are we given? We're given an inside angle, and then the hypotenuse. Hypotenuse and this angle. So usually we look at this as theta, but that's not always going to be the case. So we can still use the other SOH-CAH-TOA even if that one's not our angle. So I'm going to go ahead and find if I can use either Sine, cosine are one of those functions with 72 degrees as the angle in it, and then apply 8 and x with it. So that's going to be hypotenuse, and the value here, if 72 degrees is our angle, that will be my adjacent, right? X will equal my adjacent, and this one would have been my opposite. So what function has the hypotenuse value and the adjacent value in it? Well, that's going to be cosine, right? So CAH-TOA. CAH is adjacent over hypotenuse. So we're going to look at cosine of 72 degrees equals our adjacent value, which is x, we don't actually know what that is, x over h, our hypotenuse, which we do know is 8. And look, we can solve an algebraic equation. So we'll multiply both sides by 8. And we have 8 cosine of 72 degrees equals x. Now this is where you're going to go ahead and plug it into your calculator. Make sure it's in degrees, not radians. How come we need degrees? Because we are using degrees in our problem. And then when you plug that in, you should get x is about 2.5. And box our answer. Let me go ahead and box this off so we don't get our work confused with the other ones. Now let's take a look at the next triangle. As usual, always write down what you're given and then see what you can use from your toolbox, I like to call it, on solving. So what are we given here? Well, we're given this angle, we're given the hypotenuse, and across from this angle, the one opposite from it, is the one we're trying to find. So we're looking for opposite and hypotenuse. So in SOH-CAH-TOA, which one of these guys contains opposite and hypotenuse in it? Sine has opposite and hypotenuse in it. So let's go ahead and use sine. So it's going to be sine of 53 degrees should equal the opposite, x, over hypotenuse, which we have is 15. Once again, let's solve like we did before. Multiply both sides by that number. And we get 15 sine of 53 degrees equals x. Plugging that into our calculator, we get about 11.9. And once again, please use your approximation symbol. That is something that does get graded on exams. So do not use an equal sign if you're approximating. Alright, not bad so far. At least it's hopefully not that bad. And once again, if you need to set up an office hour with me, definitely send me an email and we can set up an office hour. Okay, let's see. Solving for x. What are we given here? Well, we could possibly say that this is 90 degrees, but I'm not going to bank on the fact that that is 90 degrees. So what am I given that I know? I know for certain that this is 9, and that is 10. And we have some random angle here that we're trying to find. So we're given the opposite number and the adjacent number to this degree. Remember, that's the opposite, that's the adjacent. And we're not given hypotenuse. So which trig function has opposite and adjacent in it? That's going to be tangent. Tangent has both opposite and adjacent value. So we'll go ahead and say tangent of, oh, we don't have a degree. But that's okay. We'll go ahead and tangent x degrees. We're trying to figure out what the degrees are. So it's okay if they're a variable. So tangent x degrees is going to equal opposite over adjacent. So that'll be 9 over 10. Now this is a weird problem. It's different than the other ones. Before, x was outside. Now, x is inside our trig function. How can we get out of the trig function? Well, this is where our lovely canceling properties of inverses come into play. Ta-da! Alright, let's use the inverse. So to get rid of tangent, we just apply the tangent inverse to both sides. So we'll go ahead and do, let me write it down a little further. Tangent inverse of that, so tangent of x degrees equals taking tangent of both sides. And once again, whenever you apply something like this, please show the work for both sides. This is a step I will be looking for if you ever use an inverse to see that you applied it to both sides. So I'm going to go ahead and star that step. Okay, once we do that, these guys cancel out. because 9 over 10 is within our range for tangent. And then we have x degrees equals tangent inverse of 9 over 10, which you can go ahead and plug into your calculator. Remember, to find tangent inverse, use second and then hit tangent. And please use your TI-84. Please get used to using your TI-84. And then plugging that in, we get x is about 42 degrees. And if you got a weird number that's not that, please check and make sure that your calculator is in degrees, not radians. Alright. Now let's check the next triangle. What are we given? Oops, forgot to box my answer. What are we given for the next triangle? Well, we're trying to find the degree. And on that degree, we are given, let's see, that looks like the adjacent value, because the opposite one, we aren't given that. And then we're also given the hypotenuse, which is 19. So which trig function has to do with adjacent and hypotenuse? Well, that trig function is cosine. So cosine of the value we don't know is equal to adjacent over hypotenuse. Once again, how do we get rid of that, or how do we get the x value outside of our function? Because at the moment, x is inside our function. Well, once again, this is when the inverse functions come in handy. Let's take the inverse of both sides. So cosine inverse, we'll go ahead and apply that. Please show the work of applying an inverse if you do. Cosine x, and then 14.3 over 19. When we do that, we'll go ahead and use the cancellation property, checking that this is in our domain. And then x degrees is going to equal cosine inverse of 14.3 over 19. Alright, plugging that into our calculator, we get that x is approximately 41 degrees. Okay, so now we have example 5. Evaluate the expression without a calculator. Ooh, kind of fancy. Alright, so what do we have here? We have cosine of pi over 6 plus sine 30 degrees minus cosine 60 degrees and tangent of pi over 4 squared. These are all talking about values on the unit circle. So let me go ahead and draw out my unit circle. And these are all actually values in the second quadrant. So pi over 6, if you recall, is right there, pi over 6, which is also the same as 30 degrees. And that coordinate is root 3 over 2 half. And then what else do we have? We have pi over 4. Pi over 4 is right here, which is also equal to 45 degrees. And that point is root 2 over 2, root 2 over 2. Next, the other value we are given is 60 degrees, which, if you recall, I just introduced earlier, is the same as pi over 3. And that point is half root 3 over 2. Okay, so we've got all those values set up, so it should be pretty straightforward from here. So what is cosine of pi over 6? Well, cosine, remember, is talking about the x value. So cosine of pi over 6 is going to be root 3 over 2. Plus sine of 30 degrees. So sine of 30 degrees, 30 degrees is this value here, and sine is talking about the y value, so that should be a half. Then minus cosine of 60 degrees. Where is 60 degrees? 60 degrees is right here, and cosine is talking about the x value. So that's going to be also a half. And then lastly, tangent of pi over 4. So where is pi over 4? Well, this value right here, and we're looking at tangent, which is going to be y divided by x. So that'll be root 2 divided by 2 all over root 2 divided by 2. And we're supposed to square this. Okay, so now we found all of the values for the trig functions. Let's just go ahead and simplify. So root 3 over 2, that's going to stay there. But notice the halves cancel each other out. And then this is root 2 over 2 divided by root 2 over 2. That simplifies to 1. So that'll be all plus 1 squared. Okay, let's go ahead and move my work over here using that arrow to keep things neat. Simplifying this. Well, let's go ahead and add the fractions. So that'll be root 3 over 2, and then to create a common denominator here, that'll be 2 divided by 2. So that'll be root 3 over 2 plus 2 over 2 squared, which will equal root 3 plus 2 over 2 squared. And then, putting out the answers, we'll get root 3 plus 2 squared over 4. Still got to simplify, so I'm going to go ahead and erase some of my units. Circle. Let's see, foiling out the top, we're going to get root 3 plus 2 squared, which if you recall, that's root 3 plus 2 times root 3 plus 2. Please note, that is not equal to root 3 squared plus 2 squared. You cannot just distribute the square over the plus sign. And then all divided by 4, and so simplifying out all that multiplication, we'll get 7 plus 4 root 3 over 4. Okay, so once again, if any of the smaller algebraic steps are still confusing you, because it's been a while since you took Math 135, please send me an email and I'll give you any some extra sort of work problems to help remind you of those. But once again, I am assuming that you have algebra pretty well down by the time you're in this class. But if you need help, please reach out to me. That's what I'm here for. Alright, example 6. Solve the triangle. Round to 1 decimal place if needed. So what does it mean to solve the triangle? Well, the directions solve the triangle means to find all angles and sides. This is very important. Please keep that in mind. If I say to find or to solve the triangle, that's what I mean. All angles and sides. So let's take a look at what we have here. At the moment, we are given one angle and one side, which means we need to find 1, 2, 3, 4 other items. Can you find one of those items right now? The answer is yes. See the little square down there? That means that that is a 90-degree angle. So let's go ahead, fill that in, 90 degrees. Can we find the other angle? And the answer to that is yes. So we'll say finding, and I'll call this one alpha. Why not? Finding alpha. So if you ever have a bunch of work going on, please label your work. For example, finding alpha or finding x. Just go ahead, label your work, keep it neat. So to find that, we'll do 180 minus 90 degrees minus 38 degrees, which will give us, let's see, 52 degrees. So we found alpha is 52 degrees. Now the next thing we need to do is just find the other two sides. So how do we do those? There are multiple ways I could do this, but the way I'm thinking of is if I want to find this angle right here, I'll go ahead and circle it. Sorry, if I want to find that side, I can use the angle of 38 degrees and tie in 7.8, which is what we were doing earlier. So that would mean using the hypotenuse, this is the longest leg, the hypotenuse and the, is that opposite or adjacent? Well, that's the opposite. So this would be the adjacent. Okay, so which trig function uses adjacent and hypotenuse? Let's take a look. SOH-CAH-TOA. Which one has opposite and hypotenuse in it? Or sorry, adjacent and hypotenuse. The answer is cosine. So let's go ahead and use cosine to find A. So finding, and I called it A. So to do that, we're going to do cosine of 38 degrees equals A divided by 7.8. Solving that, we get, multiplying both sides by 7.8. Those cancel. And we're left with 7.8 times cosine of 38 degrees. Plugging that into your calculator, you'll get 6.1 is roughly what A equals. So we'll put that in 6.1. And box that. And then lastly, what else do we need? we need opposite, O. So I'm saying this is equal to O. So we'll go ahead and say finding O. So here's a way to show your work. If you just went ahead and labeled all these sides, like I did with an O, an H, and an A, then you could just leave your work like this, and you don't necessarily have to label the diagram. So the last thing to find is our opposite angle. Well, the one that's opposite from 38 degrees. So now we're looking for the opposite. And you know, there are a few different ways we could do this. Because we now have 6.1, the adjacent value, we could use tangent, or we could use sine. It's up to us, but I'm going to go ahead and use sine, which means I'm going to use my values of O over H, so opposite, which is the value I'm looking for, and then H, which is my 7.8. So sine of 38. Sine of 38 degrees is going to equal my opposite, which was, we don't know, I called that O, over H, which is my 7.8. Okay, solving both sides. So notice O is a really bad variable to pick. I shouldn't have picked that. Why is it a bad variable? Just because it looks like a 0. So be careful, it's not the best one to pick. That's kind of my mistake. It's not like you can't, but sometimes you can confuse yourself. Okay, so plugging that into the calculator, we'll get sine, so O is going to be about 4.8. And there we go, we're done. So notice, there are multiple ways to find all these sides. I just decided to use cosine and sine. You could have used tangent, or you could have used the Pythagorean theorem. So there are definitely multiple ways of doing it. Now let's look at example 7. So solve for x. Okay, so what are we given and where is x? First off, x is right here, so that's what we're aiming for. And then what are we given? We're given 54 degrees, 39 degrees, 45 meters, and we know that these are both 90-degree angles. Okay, so let's go ahead and pop that in. So this is 90 degrees, and these are 90 degrees. Let's see, to find x, x is a hypotenuse. So, what are ways to find the hypotenuse? Well, if you'll remember, SOH-CAH-TOA, both sine and cosine can be used to find the hypotenuse because they both have h in them. So, let's see. If I was to use 54 degrees, I would need either the adjacent side or the opposite side to solve for hypotenuse. And I don't have either of those. So maybe I need to use something else that's given. And what else do I know that's given? I am given 4.5 and 39 degrees. Hey, so if I used 39 and 4.5 to find the opposite value, or the opposite side, for the triangle above, then I could solve. So let's go ahead and do that. So I'm going to first solve the value over here. Let's go ahead and call that, let's call this alpha, because I don't like using O. So if that's alpha, for the top triangle, that's considered the opposite side. But for my bottom triangle, let's go ahead and draw out my bottom triangle down here so it's not as confusing. So that's the 90 degrees, that's the 39, and I'm given 4.5. And I want to find the value up here, alpha, which is, let me go ahead and highlight it again, this red part. I want to find that one. And that matches up with the value here, which is actually the hypotenuse of my triangle on the bottom. So I have the hypotenuse of the bottom triangle and the adjacent value for my triangle. So which one has adjacent and hypotenuse? That would be cosine. So let's go ahead and say finding alpha. So finding alpha, we'll go ahead and use cosine. Why are we using that? Because the values I have are the adjacent, and I really want to find this value right here, which would be that number. So the cosine of 39 degrees is going to equal adjacent over hypotenuse, so that'll be 4.5 over alpha. And then solving, let's see, multiply both sides by alpha, so we get cosine 39 degrees equals 45. How did I do that? Well, I just multiplied both sides by alpha. And then divide both sides by cosine of 39 degrees. And I get alpha equals approximately, if I plug that into my calculator, 5.8. Okay, awesome. Alpha is 5.8. Why did we care about that? Well, remember, originally we were trying to find the hypotenuse of the top triangle. And to do that with angle 54, I either needed this length here or the alpha length here. Because I was able to find the length we called alpha, now I can go ahead and solve for the hypotenuse. What am I given though? So I want to say finding x. So I'm using angle 54, and I am trying to use alpha, which I know alpha is equal to 5.8, and I want the hypotenuse. So that is the opposite. Let me go ahead and clean this up here a little bit. So I'm going to be using the opposite side and the hypotenuse in my equation. So which trig function consists of the opposite length and the hypotenuse? Opposite and hypotenuse. That would be sine. So we're going to go ahead and use sine. So sine of, and we're using angle 54, sine of 54 degrees equals the opposite value, which is 5.8, divided by the hypotenuse, which is x, what we're searching for. So solving for this, we'll go ahead and multiply both sides by x. Then we get x sine of 54 degrees equals 5.8. And solving for x, we're so close. Sine of 54 degrees, we'll get x is equal to 5.8 divided by sine of 54 degrees. Plugging that into our calculator, we get x is approximately 7.2. And there we have our final answer, x equals 7.2. So we really had to build off of this. We had to go to the other triangle to find a side that we needed, and then we could finally complete our problem. Once again, it's just sort of solving a puzzle using what you have. And as usual, if you ever need a further explanation on any of these problems or examples from the videos, just set up an office hour with me and I'll gladly go over any of these examples with you again. So now, the last example, example 8. A boat drops its anchor. Okay, so you have a boat, drops its anchor, and usually what happens, once the boat drops its anchor, I don't know if you've seen Pirates of the Caribbean, the boat still continues a bit of a ways, right? Why? Because the anchor needs to catch hold of something. So an angle is created. The anchor chain is 30 meters. Okay, so we know the length of the chain, it's 30 meters. The angle formed by the ocean floor is this right here, it's the ocean floor. And the anchor chain is 39 degrees. That's the angle formed. What is the distance from the boat to the ocean floor? So we want to find D. All right, let's go ahead and think. Okay, so we've got angles and legs. So I know I should be thinking of, more than likely, SOH-CAH-TOA, right? SOH-CAH-TOA. Because that's a way of connecting the angles in a triangle and the legs of a triangle. I just need to figure out which one to use. What am I given? I'm given this angle, and then from this angle, I'm given the value that is opposite it and the hypotenuse. Those are the things I'm given. The opposite value and the hypotenuse. So which one of these functions has opposite and hypotenuse? That is sine. So let's go ahead and use sine. So sine of, and what angle do we have? 39 degrees. Sine of 39 degrees is going to equal opposite, which is D, because that's what we're looking for, divided by the hypotenuse, which is 30 meters. And solving, so multiplying both sides by 30 meters, or 30. Those cancel, and we have 30 sine of 39 degree meters equals D. Plugging that into your calculator, you should get 19, about 19. So G is approximately 19. And once again, this is a word problem, so how should we answer? We should answer in word form. So one example would be the distance from the boat to the floor, ocean floor, is what? Is 19. Careful, we need to include the units. What are the units? Meters, 19 meters, and our period. Okay, and then there is a practice problem. Once again, I will have those uploaded by the end of the week to check. They are not due for or they're not part of your grading for the summer session. And that is it for section 6.2.